Yes! Have you ever walked into a calc class and asked yourself, what the heck is going on? Are you kidding me? Traditional learning today is just giving you piece after piece. And you're sitting there wondering, what do I do with all these pieces? Because you haven't been shown what the picture looks like on the outside of the box. It's like, oh, thank you for giving me this red piece. Now I know what some of you were thinking. Calculus is too hard for me. Well, I invite you to reflect inward and realize how unbelievably amazing you are. The average person has a mental word bank of 20 to 30,000 words. And you're pulling specific items from a mental set of possibly over 20,000. Stringing them together in a specific order to convey a very deliberate message flawlessly. And you're telling me calculus is too hard? Trust me, calculus is easy. Now maybe you're thinking, why should I learn this if I'm never gonna use it? If you don't know what calculus is, how on earth would you know if you could use it or not? But in case you don't believe me, I've compiled a small list of some of the more obvious uses calc has. But the truth is that calculus is an extension of reality that you didn't know about. The truth is that calculus is truth. The truth is that you haven't lived until you've learned
calculus the right way.
What is calculus? This seems to be the question that everybody's asking, but nobody seems to know. Calculus is the branch of mathematics that deals with the finding and properties of derivatives and integrals of functions by methods originally based on the summation of infinitesimal differences. The two main types are differential calculus and integral calculus. Think back to when you were in grade school, when you learned about how addition was the opposite of subtraction. How subtraction sort of undoes what the addition did, right? Addition, subtraction, multiplication, division, exponents, and radicals. Well, now let me introduce to you differentiation and integration. Now, differentiation has to do with the derivative. The derivative is an operation that can be used on a function that graphs its slope at any value of x. Do you remember doing slopes of linear functions? The slope is the rise over run or the change in y over the change in x. Well, for any function that isn't a straight line, the slope is changing. The slope is change and it's changing. Here we have a random function with its derivative. You can see the derivative's y-coordinate is always the slope of the original function at x. The derivative graphs slope. The derivative graphs change. Everything in life is always changing. Now, Sir Isaac Newton understood how important the derivative was as it relates to physics. He realized that a function that described the position of an object was a graph of the position versus time, and that the velocity function graphed the rate of change in position versus time. And also that the acceleration graphed the change in velocity versus time, or rather, the change of position versus time. Newton understood how these functions related to each other. That an operation, later called the derivative, could get you from one of these functions to the one below it. Of course, there's another function for the change of acceleration versus time. Jerk. Jerk. Seriously, jerk. But you already knew this. Have you ever been in a car that stopped suddenly and you jerked your head? Well, the sudden stop was a sudden change in acceleration. Therefore, you felt jerk. Good old Isaac introduced this fancy notation with the variable of the function with a dot over it as the derivative and two dots as the second derivative. Mathematicians can't seem to agree on a standard notation for the derivative, so they use a whole bunch of them to confuse you. All of these notations mean the exact same thing, so burn that into your brain and let's move on. For those of you who are still convinced that calculus isn't useful for you, consider this. When a curved slope is 0, you either have a maximum or a minimum. I will repeat this, bananas. When a curved slope is 0, you either have a maximum or a minimum. Do you understand the significance of this? You can use the derivative, set it equal to 0, and get the maximum efficiency of anything. How important is it to be efficient? Everyone in the workforce is always trying to increase efficiency. Let me give you an example. Say you're selling hot dogs, and you have a function to describe how much money you'll make in one day, depending on the price you set on the dogs. You charge too much, and no one will buy the delicious meat. You charge too little, and you won't make any money from it. What is the optimal price you should use? Calculus has the answer. Take the derivative, set it equal to 0, and solve for the variable. And then you'll know the best price to charge for your awesome snacks that send your customers to hot dog heaven. How could you not see the use in that? Okay, now for the integral. Even though integration is taught after the derivative in school, uses of the integral date back to ancient Greece. Why were they able to do this? Brace yourself. The integral is the area under the curve. Of course, the ancient Greeks could figure out why the area under a curve is useful. If you have a graph that represents the rate of anything, the integral gives you a total amount of that thing in a given time frame. So let me throw a few examples out there. Taking the integral of a graph of traffic flow will give you the total amount of cars that have gone by in a specific time frame. Or, if you take the integral of a function that represents the flow of water, it'll give you the total volume of water there is. Now, when you learn about this in school, they start off by calling it the antiderivative. Maybe they think that'll give you the hint. But you know who got the hint? Gottfried Wilhelm Leibniz. Leibniz realized almost 2,000 years after the ancient Greeks started using the area that the integral and the derivative were intertwined. It took mathematicians that long to figure out that the slope and the area are opposites. This is the fundamental theorem. So the next time someone asks you, what is calculus? You tell them that calculus is the study of how the area under a curve and its slope are related. Thank you for watching my video, and peace out.